Welcome to your deep dive into API design. Looks like you've been digging into some pretty dense material on this. We've got excerpts from a couple of books, Practical API Design and REST API Design Rulebook, plus a Medium article on design patterns. So are you building an API from scratch? Trying to level up your dev skills? Whatever your mission, we're here to help you extract the most valuable nuggets of knowledge from this stack of info.
And it's a fascinating stack, too. We're talking about everything from avoiding common pitfalls to the philosophical underpinnings of good design. There's even a section on how API design principles are reflected in, wait for it, the laws of physics.
Okay, I have to hear more about that, but first let's set the stage. You've got all these sources talking about API design patterns, essentially, reusable solutions to common problems, right?
Exactly. They're like blueprints for building robust, user-friendly APIs. And just like in architecture, using proven patterns can save you a lot of headaches down the road.
And speaking of preventing headaches, the Medium article dives straight into patterns that can help prevent APIs from becoming overloaded. It brings up rate limiting as one way to control the flow of requests. So how crucial is rate limiting?
Rate limiting is crucial for stopping abuse and maintaining stability. Imagine a massive surge of requests hitting your API all at once. Without rate limiting, your servers could get swamped, and everyone using the API would experience problems. It's like having a digital bouncer at the door, making sure things don't get out of control.
It's a great analogy. The article also discusses caching, which is all about optimizing performance. By storing frequently accessed data in a cache, you can avoid repeatedly fetching it from the main database, right?
Right. This can significantly speed things up. The article mentions different types of caching too, client-side, server-side, and CDNs. Essentially, data can be stored in multiple locations for faster access.
So it's like a network of libraries, each with copies of the most popular books. The closer a library is to someone who wants to read that book, the quicker they can access it.
That's a great way to think about it.
Now, practical API design delves into an intriguing concept, having separate APIs for clients and for providers.
This idea really gets to the heart of understanding why well-designed APIs are so important. The author compares it to how our understanding of the universe evolved. Early astronomers could observe how planets moved, but they didn't fully grasp why.
Could you say that having an API without understanding its deeper purpose is similar to those early astronomers just observing the what without the why?
Yes, in a sense. Just like later physicists discovered the laws of gravity to explain planetary motion, good API design involves understanding the underlying principles that make it function properly.
So you're saying it's not just about writing code, but writing code with a clear vision of how it fits into the bigger picture. How can I actually apply this concept of understanding the why when I'm designing my API?
That's a great question. One way is to think about the different perspectives of those interacting with your API. This ties back to the idea of separate client and provider APIs. Just like there are different levels of understanding the universe, you need different levels in access and functionality for those using your API.
So the client API would be focused on providing the tools for users to get things done, while the provider API would enable developers to extend and build upon the system itself.
Exactly. And that emphasis on understanding different needs is a recurring theme in good API design. For example, practical API design stresses the importance of designing for testability.
That makes sense. We need to ensure we can easily test whether our API is working as expected, right?
Right. One way to do this is with a test compatibility kit, or TCK. This is a set of tests designed to verify that an API implementation meets its requirements.
I can see how that would be invaluable, especially when making changes or adding new features. You wouldn't want to accidentally break something in the process. It acts like a safety net.
Exactly. It helps you catch potential issues before they impact your users. Now let's turn to REST API Design Rulebook. This one focuses on the principles of RESTful APIs, and it places a lot of emphasis on URIs.
One of the key takeaways from this book is the idea of using new URIs for new concepts. It explicitly advises against embedding version numbers directly into the URI. It might seem like an easy way to manage different versions, but why is it so important to avoid that?
A URI should represent a unique resource. If you change the version within the URI, it implies that the resource itself has changed, which can create confusion and violate the fundamental principles of REST.
So it's about maintaining a clear and consistent representation of resources, regardless of their version.
Right. Instead of embedding the version in the URI, it should be communicated through other mechanisms like headers.
And REST API Design Rulebook also highlights the usefulness of query parameters. Two specific ones mentioned are fields and embed.
These parameters give clients greater control over the data they receive. The fields parameter allows them to request only specific data fields that are relevant to them. So instead of getting a massive data dump, they can cherry-pick the information they need.
And what about the embed parameter?
Embed allows clients to request related resources to be included directly in the response. This can streamline data retrieval, as clients don't have to make separate requests for related information. For instance, if you're requesting a student's information, you could use the embed parameter to get their course details included in the same response.
That makes a lot of sense. Now, there's another interesting point in the REST API design rulebook, the mention of JSON. Is this a workaround for limitations in some browsers?
JSON, or JSON with padding, is a technique for bypassing the same origin policy, which restricts how JavaScript can interact with resources from different domains. However, it has a key limitation. JSON only works with JIT requests.
So it's a useful tool in specific situations, but not a universal solution for all API interactions.
Exactly. Now let's return to practical API design for a moment. It delves into the crucial topic of API evolution and versioning elements that are essential for long-term success.
The author emphasizes that the initial version is rarely perfect. Change is inevitable, especially as your API grows and you get user feedback. We'll want to make improvements and add new features.
And the book discusses different approaches for managing these changes, including the concept of deprecation.
Deprecation allows developers to mark parts of the API as outdated while still supporting them for a period of time, right? It's like giving a heads up before removing a feature entirely.
That seems like a much smoother way to handle evolution than suddenly dropping support for older versions.
It definitely helps with transitioning to newer versions. The author also gets into the technical details of how even small changes can impact compatibility.
Now, there's also a section in Practical API Design that focuses on potential challenges with subclassing and listeners, particularly within multi-threaded environments.
What's fascinating about this section is how it connects to the broader principle of managing complexity and avoiding unintended consequences. Subclassing, while useful for code reuse, can introduce issues, especially when multiple threads are involved. Similarly, listeners, which are often used for event handling, need to be carefully managed to prevent problems.
It sounds like there's a lot to consider to prevent those unexpected outcomes. What else does the book say about this?
Well, it brings up the concept of conscious versus unconscious upgrades. Some upgrades are obvious and require developers to update their code, while others are more subtle and might not be immediately apparent.
So it's like making a small tweak to a recipe. Sometimes the difference is noticeable, sometimes it's not.
That's a good analogy. And for those unconscious upgrades, the book recommends using system properties to control alternative behaviors.
So that gives developers more control over how they adapt to those less obvious changes.
Yes, it adds flexibility and allows them to toggle between the old and new behavior without major code changes.
Now, speaking of real-world examples, Practical API Design wraps up with a really intriguing one, the API Design Fest.
The API Design Fest was a competition where developers had to design and evolve an API under tight deadlines. What insights did they gain from this event?
One major takeaway was the importance of planning for the future and designing for flexibility from the very beginning. The participants faced numerous challenges trying to evolve their APIs in a backward-compatible way.
It's like trying to add an extension onto a house without a foundation designed for it. Problems are bound to arrive. This highlights how API design is an ongoing process, not a one-time event.
That's a good point. Now, before we dive into the specific challenges faced at the API Design Fest, we've covered a lot of technical ground so far, but let's shift gears and explore something equally important, the user experience.
Building an API is more than just making sure it functions correctly. We also need to consider the experience of the developers who will be using it, right? A well-designed API can be a joy to work with, while a poorly designed one can cause a lot of frustration.
That's a great point. We have another source that delves into that on the design, development, and testing of modern APIs. This report from Carnegie Mellon's Software Engineering Institute really stresses the importance of API usability. It's not just about making it work. It's about making it easy and intuitive to use.
Makes sense. The report talks about how a difficult-to-use API can actually lead to faulty programs and security vulnerabilities.
Exactly. If an API is confusing or difficult to work with, developers are more likely to make mistakes that could have serious consequences.
So it's about more than just saving developers from frustration. It's about building secure and reliable systems. What else does this report suggest?
It highlights several key aspects of a good user experience, such as discoverability, consistency, and error handling. It also suggests involving users in the design process itself.
That's an interesting idea. So actually getting feedback from the developers who will be using the API.
Yes, conducting usability studies, gathering feedback, and iterating on the design based on user input can significantly improve the final product.
This reminds me of something I read in Practical API Design. The author advocates for a more agile approach to API design where you're constantly responding to changing needs and feedback.
Yes, it's about embracing an iterative and collaborative approach similar to how agile software development principles work. The author even compares API design to shaping the digital universe.
I love that analogy. It really speaks to the power we have as API designers. We're not just building a tool, we're creating an environment for others to interact with and build upon.
And the more thoughtful and user-centered our design is, the more positive and productive that environment will be. Now let's touch on a practical concern that REST API Design Rulebook raises: security.
Security is absolutely crucial when designing APIs, especially with the prevalence of data breaches these days.
Absolutely. The book stresses the importance of using HTTPS for all API interactions to encrypt communication between the client and the server. Helps protect sensitive data.
It's like the difference between sending a confidential letter in a sealed envelope versus writing it on a postcard for everyone to see. What other security measures should we consider?
The book also emphasizes the importance of robust authentication and authorization mechanisms. This ensures that only authorized users can access the API and that they can only perform the actions they're supposed to. Techniques like API keys, OAuth, or JWTs can be used for this purpose.
We're getting into some pretty specific security details here. Do any of our other sources delve deeper into this topic?
Yes, the report on the design, development, and testing of modern APIs dedicates an entire section to API security. It recommends a comprehensive approach, considering security from the initial design phase all the way through development and testing.
So security should be baked into the entire API lifecycle, not just added as an afterthought.
Exactly. The report discusses various security risks like injection attacks, broken authentication, and sensitive data exposure. And it offers recommendations for mitigating these risks, such as input validation, strong authentication, and encryption.
It sounds like there's a lot to consider when it comes to API security. Is there anything else this report emphasizes?
It also highlights the importance of regularly testing and updating the API to address new vulnerabilities. Security is an ongoing process that requires constant vigilance and adaptation.
That makes sense. Technology is always evolving, and security needs to keep pace. Speaking of evolving technology, let's discuss an emerging trend in API design, the use of artificial intelligence, or AI.
AI is rapidly changing many aspects of software development, including API design. On the design, development, and testing of modern APIs touches on this, specifically mentioning the use of large language models, LLMs, in the design phase.
LLMs like ChatGPT can be used to generate code, explore design alternatives, and even analyze existing architectural documents. It's like having a brainstorming partner who can instantly generate ideas and provide feedback.
That sounds incredibly helpful, but are there any drawbacks to using LLMs in API design?
The report cautions that LLMs are still in their early stages and can sometimes produce inaccurate or biased results. Human experts still need to review and validate the output.
So it's about using LLMs as tools to augment human intelligence, not to replace it. Are there other ways AI is being used in API design?
The report also discusses the use of AI in API testing, specifically mentioning AI-enabled testing tools. These tools can help automate the testing process, making it faster and more efficient.
That makes sense. AI can analyze vast amounts of data much faster than a human can.
Yes, and AI-powered testing tools can even help identify edge cases and potential vulnerabilities that might be missed by traditional testing methods. This makes AI a powerful tool for improving both API quality and security.
Speaking of security, this brings us to a fascinating concept mentioned in both the report and software architecture patterns: Zero Trust Architecture, or ZTA.
ZTA is a security model that assumes no implicit trust for any user or device, even those within the network perimeter. It's like having a security guard at every single door, constantly verifying identities and permissions.
That's a very strict security model. How does it relate to API design?
APIs are often the entry points to sensitive systems and data. In a ZTA environment, all aspects of the API, including its configuration, architecture, and security controls, must be rigorously tested.
So there's a high level of scrutiny when it comes to APIs in a ZTA.
Yes, ZTAs demand a comprehensive and proactive approach to security with no room for complacency. What else does the report mention in relation to ZTA?
It emphasizes testing for vulnerabilities like broken authentication and authorization, which could allow attackers to bypass security measures and gain unauthorized access. It also mentions the concept of API integrity.
API integrity focuses on ensuring that the data transmitted through the API hasn't been tampered with in transit. It's about making sure that the data received is exactly what was sent.
Exactly. This is crucial for maintaining data accuracy and preventing malicious attacks. What does the report suggest for ensuring API integrity?
It recommends using communication protocols that support data integrity, specifically those employing checksums, MACs, or digital signatures. These mechanisms help verify that the data hasn't been altered during transmission.
That makes sense. Now, let's step back and consider a bigger picture question. How do we design APIs that are not only secure and user-friendly, but also scalable and adaptable to future needs?
That's a great question, and it leads us to some of the most powerful concepts in API design. Patterns and architectures. We have a couple of sources here that dive into this. Software architecture patterns and REST API design rulebook.
Let's start with software architecture patterns. What kind of architectural patterns are particularly relevant to API design?
The book discusses several patterns, but two that are particularly useful for API design are the layered architecture pattern and the microservices architecture pattern.
Okay, let's unpack those. What's the basic idea behind layered architecture?
In a layer architecture, the system is organized into distinct layers, each responsible for a specific function. Common layers include presentation, business, persistence, and database.
So it's like a layer cake, where each layer has its own distinct flavor and purpose. How does this apply to APIs?
APIs can be considered part of the presentation layer because they're the interface that users interact with. The API layer would handle tasks like request validation, data transformation, and response formatting.
And it would interact with the underlying layers to retrieve or modify data as needed. Now, what about the microservices architecture? How is that different from the layered architecture?
Microservices architecture takes the concept of separation of concerns to an even finer granularity. Instead of layers, the system is composed of small, independent services.
So instead of a layer cake, it's more like a box of assorted chocolates, where each chocolate represents a different service.
That's a great analogy. Each microservice is self-contained and focuses on a specific business capability.
And how does this approach relate to API design?
Well, in a microservices architecture, each microservice typically exposes its own API.
So instead of having one massive API for the entire system, you have multiple smaller APIs, each representing a specific service.
Exactly. This can have significant advantages in terms of scalability, flexibility, and fault tolerance.
REST API Design Rulebook also touches on the concept of API architecture, particularly within the context of WRML. What exactly is WRML?
WRML, or Web Resource Modeling Language, is a conceptual architecture for designing RESTful APIs. It envisions a configuration-driven engine that handles API requests in a step-by-step manner.
So it's like an assembly line where each step performs a specific task.
Exactly. Common steps include routing, media type negotiation, authorization, and error handling.
And this engine would be implemented within a web resource server, which is responsible for receiving and processing client requests.
Right. One of the benefits of this approach is that it allows for a high degree of flexibility and customization. You can easily configure the engine to handle different types of requests and workflows.
What else does WRML emphasize?
It also emphasizes using hypermedia as the engine of application state, or HADIOS.
We talked about HADIOS earlier, but a quick recap for our listeners would be helpful.
Of course, HADIOS involves providing links within API responses that guide clients to related resources and actions. It's like having a map embedded within each response, showing the user where they can go next.
This allows clients to navigate the API dynamically without needing to know specific URIs in advance. Now let's shift our focus to something crucial: fault tolerance. How do we design APIs that can gracefully handle errors and failures?
That's an essential aspect of API design. Several of our sources address this, starting with Practical API Design. What are some of its recommendations for error handling?
The author emphasizes the importance of providing clear and informative error messages, not just cryptic error codes that leave developers confused.
Error messages should clearly explain what went wrong and how to fix it.
Exactly. And they should use consistent terminology and formatting throughout the API. The book also recommends using standard HTTP status codes to signal the type of error.
So things like 400 for bad requests, 401 for unauthorized access, and 500 for internal server errors.
Right. These status codes provide a standardized way for clients to understand what kind of problem occurred. REST API Design Rulebook dedicates an entire chapter to error handling as well. What insights does this offer?
The book provides detailed guidance on using HTTP status codes effectively, including specific rules for each code. It stresses going beyond the general meaning of the codes and using them precisely and consistently.
So it's not just about knowing what the codes mean, but understanding the nuances of how to apply them correctly.
Exactly. The book also emphasizes providing helpful error messages in the response body, especially when the status code alone isn't enough to diagnose the issue.
So providing additional context or troubleshooting tips can really help developers resolve the problem. What about the format of the error responses?
The book recommends using a consistent format, such as JSON, for error responses to make them easy to parse and process.
Now, the report on the design, development, and testing of modern APIs also touches on error handling, specifically emphasizing the importance of testing for error conditions.
Thorough testing is crucial to make sure the API gracefully handles errors and provides useful feedback to clients.
And this testing should encompass a wide range of scenarios, including invalid inputs, unauthorized access attempts, and unexpected server errors. The goal is to find and fix potential error conditions before they impact real users.
Now let's move on to another vital aspect of API design: documentation.
Documentation is often overlooked, but it is absolutely essential for an API to be successful. What does practical API design have to say about documentation?
The author emphasizes the importance of clear, concise, and accurate documentation. It shouldn't be filled with jargon or overly technical language.
So no walls of text that leave developers more confused than they were before. What kind of approach does it suggest?
It recommends writing documentation in plain language, using examples and diagrams to illustrate key concepts. It also stresses keeping documentation up to date as the API evolves.
That makes sense. You wouldn't want the documentation to become outdated and inaccurate.
Exactly. The book also suggests using a documentation generator, like JavaDoc, to automatically generate documentation from the code.
Does REST API Design Rulebook have anything to add on the topic of documentation?
Yes, it specifically mentions the importance of clearly describing each resource and its representations. The documentation should explain what each resource is, how to access it, and the kind of data it returns.
It should also describe the various HTTP methods that could be used with each resource, along with the expected status codes and response formats.
Right, so providing comprehensive information about how to interact with each resource is key.
Exactly. The book also recommends using tools like Swagger or API Blueprint to create interactive documentation that allows developers to test API calls directly.
So it's about making the documentation as user-friendly and practical as possible.
Absolutely. Good documentation could be a game changer for how easily developers can understand and use an API. Now, before we wrap up this section, I want to bring up one last important concept: API evolution.
API evolution is about managing changes to the API over time in a way that minimizes disruption for existing users.
And practical API design goes into depth on this topic. What are some of its key principles for managing API evolution effectively?
The author highlights the importance of maintaining backward compatibility.
This means making sure that changes to the API don't break existing code that relies on it.
Exactly. This might involve techniques like gradually deprecating old functionality, providing clear migration paths, and using versioning strategies.
The book also explores the challenges of balancing compatibility with introducing new features and improvements.
It's a delicate balancing act. What does REST API Design Rulebook have to say about API evolution?
It recommends using new URIs for new concepts rather than embedding version numbers directly in the URI. This helps maintain a clear and consistent resource model, even as the API evolves.
Does the report on modern API design offer any insights on this topic?
Yes, it highlights the importance of considering evolution from the very beginning of the design process.
Designing for flexibility and anticipating future needs can make managing changes much smoother down the line.
We've covered a lot of ground in this deep dive, from technical details to user experience to the ever-important aspect of security.
And we ended the last section on the idea of API evolution and how to manage changes effectively. But now I'd like to shift our focus to a topic we haven't explicitly discussed yet: the role of ethics in API design.
That's an important consideration. It's easy to get caught up in the technical aspects, but as API designers, we have a responsibility to think about the broader impact of our creations.
Absolutely. Our APIs can have a profound impact on how people interact with technology and with each other. We're not just building tools, we're shaping a part of the digital world.
That's a great way to put it. Now, I know there's no one-size-fits-all answer when it comes to ethical API design, but are there any guiding principles we can keep in mind?
Well, one important principle is transparency.
So being open about how our APIs work, what data they collect, and how that data is used.
Exactly. Users have a right to understand what's happening behind the scenes when they interact with an API.
And that transparency should extend to the design process itself.
I agree. Involving users in the design process can help ensure that the API aligns with their needs and values. It's a collaborative effort.
It's about co-creation, not just imposing our own ideas on the world. Now, another crucial aspect of ethical API design is fairness.
That makes sense. We need to make sure our APIs don't discriminate against certain groups or perpetuate existing biases.
Absolutely. We need to carefully consider how our design choices might impact different users, especially those from marginalized communities. It's about building inclusive APIs that benefit Everyone.
So it's not enough for our APIs to simply function correctly. They also need to be designed and implemented in a way that's fair and equitable.
Exactly. And that leads us to another important principle, accountability.
That sounds crucial. What does accountability mean in the context of API design?
It means taking responsibility for the consequences of our APIs, both intended and unintended. We need to have mechanisms in place for addressing issues like data breaches or misuse.
It's about being proactive and responsive. Now let's bring this back to some of the sources we've been discussing. The report on the design, development, and testing of modern APIs touches on several ethical considerations, particularly in the context of AI.
That's right, it highlights the potential for AI-powered APIs to amplify existing biases if we're not careful.
For instance, if an API uses a biased dataset to train its AI models, those biases will be reflected in the API's output.
Exactly. And this can have serious real-world consequences. The report emphasizes the importance of carefully selecting and curating the data used to train AI models, making sure it's diverse, representative, and as unbiased as possible.
So we need to be mindful of the data we're using and the potential biases it might contain.
Absolutely. And it's also crucial to develop robust testing methods to detect and mitigate potential biases in AI-powered APIs.
So it's not just about building AI-powered APIs, it's about building them responsibly.
Exactly. Now, another ethical consideration that the report highlights is privacy.
That's a big one, especially in today's data-driven world.
APIs play a crucial role in data collection and sharing, so we need to design them with privacy in mind from the start. The report recommends minimizing data collection, only gathering what's absolutely necessary for the API to function.
That sounds like a good starting point. What other privacy-enhancing techniques does the report suggest?
It recommends using techniques like data anonymization and encryption to protect sensitive user data. It's about respecting user privacy and giving them control over their own data.
Practical API design doesn't explicitly discuss ethics, but it does emphasize the importance of user-centric design.
Right. The author argues that APIs should be designed to meet the needs of their users, not just the convenience of the developers.
That means considering factors like usability, clarity, and consistency. It's about building APIs that are a pleasure to use, not a source of frustration.
I like that way of putting it. Now let's shift gears for a moment and talk about a specific type of API that raises some unique ethical considerations: query languages.
The report mentions query languages like GraphQL, highlighting their potential for both good and bad.
Query languages give clients a lot of power to request specific data, which can be incredibly useful. But it also raises concerns about data security and misuse.
A malicious actor could potentially use a query language to extract sensitive data from an API if it's not properly secured.
Exactly. The report emphasizes the importance of having strong authentication and authorization mechanisms in place for APIs that use query languages.
So it's about finding the right balance between flexibility and security.
Right. And it also recommends limiting the complexity and scope of queries that clients can make to minimize the risk of data exposure.
Now let's return to our discussion of API architecture. We talked about layered architectures and microservices, but there's another pattern that has some interesting ethical implications: the event-driven architecture.
Event-driven architectures are all about decoupling systems and enabling asynchronous communications.
That's right, but while the book Software Architecture Patterns describes how this pattern works, it doesn't explicitly address the ethical considerations.
But they're definitely there. For example, when events trigger actions in other systems, it's important to think about the potential consequences of those actions.
What if an event triggers an action that has negative downstream effects?
Exactly. We need to carefully consider the potential ripple effects of events, especially when dealing with sensitive data or critical systems.
It's about anticipating potential consequences and building in safeguards to prevent harm.
Right. And it's also about transparency. Users should be aware of how their actions might trigger events and what those events might lead to.
So it's about building trust and accountability into the system.
Precisely. Ethical design isn't just about preventing bad things from happening. It's also about enabling good things to happen.
It's about creating APIs that empower users, foster collaboration, and promote positive change.
And that brings us to the end of our deep dive into API design. We've explored a wide range of topics, from technical details to architectural patterns, and we've even touched on the ethical considerations that come with shaping this digital landscape.
We've learned about best practices for building secure, user-friendly, and adaptable APIs, and we've explored how emerging technologies like AI are influencing the world of API design. design. But perhaps most importantly, we've discussed the responsibility we have as API designers to consider the broader impact of our creations.
Because ultimately, it's not just about writing code, it's about building a better digital future for everyone.
So, as you continue your own exploration of API design, remember to keep these principles in mind. Build with intention, build with empathy, and build with the future in sight. Thanks for joining us on this deep dive.